So yes, this one is the circuitry one, which we had done yesterday only, and week prior also we went through the description of how to make the circuitries in the Tinkercad platform. So I believe each and everyone's doubt is clear for now. And apart from the circuitry, from the morning itself, I was like encouraging each and every team members to like go for the design stuff. And today I will love to like print some of the design and show you the basic steps to take care of while going for any development like the rapid prototyping. And you well know why the rapid prototyping is important for all of us as a STEM educator, right? So even though like some of the design I love the most, Jaya ma'am submitted the design, more design from the Jaya ma'am and Kirti sir, Kirti Nayak. And Kirti Nayak sir, like, okay, Kirti Nayak sir submitted a nice
Oh,
project.
this is good.
Maybe he tinkered, or I don't know. If Kirti Nayak sir is present in the classroom, then please help us with your insight, how you started and completed this project. This one is really very good.
This is wonderful.
Yeah. So apart from this, we do have other design as well. The reason why I'm keep mentioning one name, that is Jaya Megwani ma'am, because she tried a lot. She tried a lot. And also Lakshmi Subramanya ma'am, CS Learn, or Nirmala ma'am, you just started, I believe. And apart from this, Bhagyasri ma'am, and yes, Kirti Nayak. One more great design by Kirti Nayak, sir. Okay. So this design is also amazing. Like he literally invested a lot of time to complete this design in Tinkercad. So yes, that is great. Anyone completed the pattern design, which was mentioned in the PDF? Anyone else tried for the same? So I
Yes,
want to like close the chapter by today of the chapter of Tinkercad. I should close this chapter by today. Otherwise, what will happen? We will invest more and more time in this platform only, and we will not get the time to explore other platforms like the MIT App Inventor and Arduino programming, as well as Scratch level programming, which I promised earlier to start with, right? So if you all can able to like complete the design from the PDF itself, then it will be enough for you to like go through each and every tools and each and every models, not each and every models, but yes, each and every tools you will use throughout the journey. So it will be a great outcome in your design procedure. So let me help you with one of the design, then we will discuss about the circuitry, so that the design section will be completed, and then further we'll move on the circuitry.
Sir,
Yes,
excuse
yes,
me,
ma'am.
sir. Sorry to disturb you in between, but I would request you keep this open for at least this entire week, this coming week, and then close it. I mean, your classroom, so that
I'm
we
not
can
closing. I'm not closing any of the things. Like we done some of the design work in Tinkercad platform, and like the design work and the circuit simulation in Tinkercad. But the circuit simulation is not yet completed. Only the basic components we utilized in the circuitry. So it will go on and on. There is no issue on that. But as per my point of view, I should start other topics as well in between, so that it will be helpful for you to like cope up with the programming stuff along with these things. Because
Okay.
Just a
so
request,
what we can do,
Sourbh ji, is
yes,
it possible to close this design and proceed with the circuits and coding? Because we can
yes,
always,
yes,
dirty our hands and then learn this design. But then I think we will require more guidance in the circuitry as well as in the coding
yes,
section. So
that
if
is
we can
that
close
is what
this
I'm trying
design,
to
then
say,
I think
ma'am.
we'll have saved
Yeah,
more
yeah.
time.
So let me finish one of the design first today, and then we will move on to the circuitry. We will have 2 or 3 simulations and the first program in the Tinkercad platform. Then from next week onwards, I will explain each and everything related to Arduino IDE programming, or like we can say that embedded C++ programming. We will start that section and continue with our journey in the programming stuff itself. So in mid between, if anyone do have any doubts related to design, circuitry, or programming, they can directly ping over to the group so that I can able to arrange one short sessions like 15 or 20-minute session to clear their doubts in between.
So I have one doubt.
Yes, ma'am.
If you can just tell me about the parallel connection, if you can just demonstrate it, that circuit.
Yeah.
Just that one I have a problem.
Okay, no worries. First, let me complete one of the design which was complicated for all of you. I got the request for this particular design. Then I will move back to the circuitry. Just allow me 10 minutes to complete this one, and I will move back to the circuitry. Okay. So yes, so I'm just dragging the petal design, the flower design, which was the last design in the PDF itself. So the petal design needs one sphere on the work plane. So whenever you drag the sphere in your work plane, you will get the opportunity to change the dimension. As I mentioned earlier, the black dots or the black square dots is responsible to directly drag and drop the things to change the length, width, or length, width only, not the height. And white dot also is responsible to change the length and width, but white dot, through the white dot, we can able to change the exact dimension we required in our model stuff. So right now we don't need to go for any specific dimension because we are just going through the conceptual understanding. So I'm just dragging it a little bit in here and increasing the length and reducing the height of this particular thing. So now it looks like one of the petals, which was mentioned in the PDF also. So I do have one of the petal, and let's use some of the tools to like replicate this petal and make a complete flower out of it. So what I'm going to do, I'm just going to click on this petal and I will hit, you can see Control D option is there to like duplicate and repeat. So I'm just going to press one time Control D, and then I will click on this angle and change the value of this angle to 22.5 degree. So the time when I will hit enter, I should not wait. Please do not try to press anywhere else. Just leave it like that and continuously start pressing Control D again and again to replicate the flower petals to form the complete flower. So now we do have the petals. So just click on the color to change any of the petal color to your desired one so that it will look good. As well as I will go for this particular 3D printing for this object only. So I'm just dragging and dropping in here the colors. I'm changing the colors, or the 3D printer won't recognize the colors. So it's better to like select all of the things and combine it. So it will form a complete shape in here. So it will union each and every petals like the grouping itself. So now the whole body is, each and every petals formed the whole body. So after that, for the 3D printing stuff only, just click on the export button and export the STL file. Your model will be downloaded, and then further just click on the model itself. So you have to download this software. Maybe it is visible to you or not because the Tinker CAD screen is only shared. Okay, let me share back this particular screen so that it will be visible to you as well. Okay, just allow me a second, please. So now this software opened up, and you can see the software which I'm using is Cura. So you can see this similar petal we designed in the Tinker CAD. Now it is in here, and through this, what we can do, we just have to click on slice because all of the parameters earlier set by me, which I will explain in my future classes as well. So just go on the click, and here you can able to see the layer by layer deposition of material in this thing. So through this, we can able to like design anything. The Tinkercad platform is used to design the object, and using Cura, what we are trying to do, we are saving it as G code, that is geometrical code for the 3D printing. So let's stop this journey today for the 3D printing. I will explain those things on my other classes. So better to resolve the doubts today and move back to the other things. Okay. So now the Tinkercad profile is again visible. So I'm going back to the Tinkercad section. So I am just opening the activities and clicking on the circuitry simulation. I'm just clicking on new circuit and new design and circuit. Yes, ma'am. Your doubts, please. The parallel and series connection, right? So shall we keep the Sunday as to clear the only the doubts or the new lessons? Because and where to submit. Kavita ma'am asked me where to submit the assignment. For batch 1, you have to wait for another 1 or 2 days. It will be directed to the group itself. Like the batch 2 already got the issuance of the assignment and LMS stuff. You will receive the same. Just hold for a while because I already covered several classes, right? 6 to 7 classes already being covered in the class in this classroom program. So there need to have each and every course content details, each and everything I taught in written format. So you have to wait at least 1 or 2 days to get it reflected. And similarly, for the assignment thing, you guys like the batch 1 people will receive the one examination section. So each and every question will be composed in complete 20 set of questions or similar. Then you have to submit that only. It will be enough for batch 1 to like qualify for the same. So you don't have to worry about anything because I'm taking care of this batch. So just be with me. I will help you out by resolving each and every doubts in this. So ma'am, may you please help me with the question like you asked earlier?
Sir, I was having problem in the parallel connection.
Okay. Have you submitted the design, the circuitry in here so that I can see it over?
No, sir, just I was trying. I did go for the battery connection in the series once I had it, but I didn't go for, matlab means I couldn't try. I was trying in that only breadboard. I was trying for the parallel connection, but I couldn't do it.
Okay. So if you bring anything like the battery itself, like 2 of the battery, and if you just rotate the battery to make it perfect for the position in breadboard, then what you will left with is the need of connections, right? So I'm just dragging and dropping these thing here and mirroring this thing out so that the positive terminal remain on the positive side of breadboard and negative terminal will be on the negative side of breadboard. So now we do have 2 of the batteries. So let me open the Jamboard first so that okay. So I'm creating a new jam in here. Yes, now the screen is visible, I believe. So whenever to add on something, to add on like the batteries and other stuff, what we need to do, suppose we do have one of the battery, it does have 2 of the polarities, right? First one is the negative and second one is the positive. So one battery, we can name it as battery 1. And if we take another battery with the same negative and positive polarity, the battery 2 itself. So what we need to do, series means if we do have any of the battery which does have 2 of the ends, A and B, and another battery we do have is the C and D. Okay. So C and D, then whenever we go for this series connection, then what will happen? This one is negative and this one is positive. This one is negative and this one is positive. So what we will do for this series connection, we will connect positive to negative ones. Positive to negative ones. And after that, what we will have is the negative value. And here we will get the positive value from battery 2, the second battery itself, battery 1 and battery 2. So through that, we will have both of the wire to connect any of the electronic component. That is the reason why obviously, the reason why we connect the batteries in series to increase the voltage. In simple term, to increase the voltage, suppose battery 1 does have the potential of 1.5 volt and battery 2 does have the similar potential of 1.5 volt, then in series connection what will happen? 1.5 plus 1.5, it will become the 3 volt in total. The capacity will remain same. You already heard of one term while using your mobile phone, that is the mAh capacity, milliampere hour capacity, right? How much hour it can able to supply the power to the mobile phone. So that won't change because we are keeping the battery in series. In series, that won't change. Whatever the battery 1 does have the power wattage and battery 2 have the means, if anyone does have the higher power outage, then total we will get that power outage only. But in combination, in series, we won't get any higher power outage. It will remain constant all the time. But in parallel, what we are doing, we are connecting the two of the pins like A and B, and here we do have is C and D. So this one is negative again, this one is positive, and this one is negative, and this one is positive. So what we have to do is we will connect the negative to -1 and positive to +1. This symbol is represented to like to so that this wire is not interconnected. Okay, so B is connected to D and C is connected to A, and we have to take out one wire from this and one wire from this. Then we will have the positive terminal in here and negative terminal in here in parallel connection. So in parallel connection, what will happen? Voltage will remain constant. Voltage will always remain constant, but the capacity, the current carrying capacity, or we can say the amperage or the wattage will increase. The capacity will increase so that one battery can able to supply the power for say 1 hour, then combine in parallel connection 1 hour, and this one provides alone 1 hour. Then in combination, in parallel combination, we will get total 2 hour of battery backup, means battery backup will improve. And in series connection, we will increase the potential, the voltage coming from the battery, but the capacity will remain constant in this one. Capacity will be constant in this one, right? I believe your doubt it is clear in this. So now what we do have is the battery. If we bring any of the like multimeter in here to take the voltage or the current thing to measure the voltage and current in here, and if we connect the wires of one of the battery, like say positive to -1, and then we'll take another wire, we will connect this particular positive to in here, and I will connect, okay, not the red one. Red is representative of the positive terminal, so we won't use the red color in there. So now I'm connecting it in here. So let's hit the simulation. In combination, you will get 3 volt. So if I remove this wire from in here and connect directly to the terminal of one battery, then yes, you will get 1.5 volt in total. But in combination, in series combination, the voltage will increase to 3 volt. So 3 volt. And now look, if the battery is in series connection, then the current total amount of current is 3 ampere in here. Let's connect the battery in parallel connection and see what happens next. So in series, you already seen that we are getting V is equal to 3 volt, and current, the I, the value of I we are getting in here is 3 ampere.
Yeah.
Right, in series. So let's see what will happen in parallel and understand the concept through the practical example, not through the another method. So I'm stopping the simulation and connecting the positive wire to positive wire. So I'm connecting this to the positive one, and why there is need to use the breadboard. There is no need to use the breadboard for understanding of this, right? So I'm taking one of the wire and connecting the positive. Let me rotate, mirror this battery so that positive end will come on one side. And again, I'm connecting the positive to positive, and I'm taking another wire to connect the negative of battery to negative of another battery. So now we connected the battery in parallel. So let's see what happens uh, with the multimeter itself. Let's see what will happen. So I'm changing the color back and taking the normal wire, just connecting the wire to in here. So it's done. So now it's done. Let's start the simulation. So you can see the amperage increased. So in parallel, the V and I, let's see what happens to both of the ampere, the current carrying capacity increased, that is 6 ampere. And let's see what happened to the voltage. So voltage will remain same in parallel connection. So voltage in here we got is 1.5 volt. So now you can correlate these two in between. So in series, V will become, the V equivalent will become like this, V1 plus V2, and I will remain constant. And in parallel, V will remain constant, and I in here became I1 plus I2 for the battery itself. Do not compare it with other components, otherwise you will get confused in that. So V and in here and V and I in here. This is the basic method to like sum up each and everything, but only for the power. But we never try to connect the batteries in parallel connection. Most of the time we do not connect the batteries in parallel connection, because what will happen, suppose if one battery is less charged compared to the another battery, the battery one is less charged, does have less charge compared to the battery 2, then what will happen, this particular battery, the battery 2 will start charging the battery 1. So we won't do that thing in the circuitry itself. We always take the series connection whenever we go for the batteries, means power outlet. Whenever we talk about the power outlet, we will utilize the series connection only, not the parallel ones. Parallel ones, yes, you can go for that, but only when you do have two new pairs of battery, which does those having the capacity of like 1.5 volt or 3.7 volt each. If you are sure by testing it using the multimeter that both of the battery does have same potential, then only go for the parallel connection. Otherwise, one battery will start charging the other battery and you will lose the power in between. And it will also decrease the efficiency of batteries. So in series, you will get combined voltage. V is equal to V1 plus V2. So when if one battery is down, like one battery is giving 1 volt of power supply and other battery is giving 1.5, then in total you will receive 2.5 volt in total. So why to go for this series connection in batteries? Because whenever we do the work like the okay, not the rocketry, we will do the work in STEM and robotics. While developing any of the robotics project, you will come to know you have to utilize one of the battery, that is 18650. That is the Li-ion battery. That is most commonly used battery in the STEM and robotics thing. So whenever you will go through the any project, you have to utilize this battery, because the Li-ion battery does have one of the capability that we can able to recharge this battery for again and again, and it almost works for 3000 to 10,000 cycles. So it will be good to utilize the Li-ion battery in your application, and do not go for that 9 volt battery or like other pencil battery or AA or AAA's batteries. Do not try to utilize these batteries, because this is money consuming. These batteries are money consuming and you have to buy these batteries again and again. But once you will purchase the 18650, then it will last long for 1 year at least, if you use it properly and charge it in continuous interval. It will give you the proper response. One of the battery I'm using for my bot, which I developed earlier, like I charged that battery, I believe 2 months or prior, but still now I'm utilizing the same. It does have good current carrying capacity and the power factor. So you should use, but whenever you use these batteries, try to be careful with the Li-ion battery, because why I'm saying to be careful with the Li-ion or LiPo kind of batteries, because if any by any chance, if these batteries, the internal circuitry of this battery comes into contact of air, then it will start burning itself, and further it will explode. So be careful with the lipo batteries. Like you may be heard of the mobile phone explosion or something like that because of these batteries. So you have to be careful all of the time during your classroom program, otherwise it will cause a serious damage to the components as well as the human life in there. So make sure you'll follow the safety rules while having these things. So I just explained you the parallel and series connection, but the batteries, the power should not be connected in parallel, as I mentioned. But for the components like the LEDs and other things, yes, you can go for the same. For the components, you can utilize the series and parallel connection, and it won't affect anything in between. So suppose if I'm bringing one of the LEDs in here, just grab one of the LEDs, and this one is cathode and this one is anode. So, okay, so I'm changing the wire color, the green one, and taking the cathode and connecting it to the power source, to the negative one. And I'm again having taking the black wire and connecting this one in here to the positive of the battery. Let's see what happens in combination, in parallel connection. So in parallel connection, see the voltage, as we assumed earlier, the voltage will remain 1.5 volt and it won't affect anything in the LED itself. But what will happen if we change the circuitry, or just I'm deleting one of the things. So now we connected the positive in here. Let me take one more wire, preferably the red one, and connect the positive to the negative of this battery. So what will happen? You can see something is happening, like more current is flowing through the circuitry. So whenever you are connecting the batteries in series, then to make sure you are utilizing enough power for the application itself. Otherwise, it will damage the component in the circuitry. So it's better to utilize the coin 3 volt batteries in your application, as many of you do have that battery in excess, and that battery lasts longer than the AA batteries. So you can utilize those batteries. And if you don't have these particular battery, then I will help you with one of the tip and tricks in this class today. So let me remove each and everything and let me introduce the application of transistors. As I mentioned earlier, you can able to utilize transistors for three of the basic purposes. First one I
Sir,
mentioned. Yeah. Yes, ma'am.
sir, we don't have to use the breadboard to do the connection. We can do it even without that.
Yeah, for our understanding, we can go for without breadboard stuff, but for the student perspective, you should follow the procedure of utilizing the breadboard in your classroom. Otherwise, what will happen if you are using the LED, its pins or the terminals are so delicate that you cannot able to reutilize that again for any of the projects. So you must utilize breadboard for each and every project. For the smaller like LED glowing, from the LED glowing to the Arduino stuff, you should utilize the breadboard in between. Otherwise, you will damage your component, and it is not advisable to do this circuitry without using the breadboard in the practical application.
Thank you, sir.
So now I'm bringing one of the LED in here, and let's find out one of the transistor from the that is the 7805 regulator. So I'm just placing the 7805 regulator. The LM7805 is known as, whenever we try to supply the voltage like 12 volt to 24 volt, it will always give us the value of 5 volt in return. So let me show you one thing. So suppose we do have this particular transistor, the 7805. and we know it as the voltage regulator. I believe I already mentioned it in my earlier classes, the voltage regulator. So whenever we will give 12 volt or above than 5 volt, like 6 volt to 24 volt DC, then it will always convert it to 5 volt. Or it is advisable to utilize only 12 volt, 6 volt to 12 volt in this regulator, to not let it will not affect the workability of the regulator itself. So 7805 transistor, and each and every transistor does have the three legs. So three legs, the ground, we do have base, emitter, and collector, right? The base is responsible to get connected with the ground always. So it will be connected to ground to make it work. We required some of the potential to start the transistor, otherwise it won't work. So now what we do have is this setup, in which we can see the 7805 is mentioned as the three pins in 7805 is mentioned as the out pin, ground pin, and in pin. So if we bring the battery in here, like more than 1.5 volt, let's see what will happen to the what will happen to the LED. So I connected the 9 volt battery directly to the breadboard. Let's connect the wire first without connecting the batteries with the regulator itself. So I do have cathode. That means this one is the negative terminal. So I'm connecting the negative terminal to the negative one. I'm changing the color to black so that it will be great. And I'm changing the color to red to connect the other wire to the positive one. And if I hit this simulation, then you can see what is happening. It says current through the LED is 915 milliampere, while absolute maximum is 20 milliampere. So now you do have a proper idea like what is happening in here, right? So we are trying to like overpower the LED with our voltage and current. So this is not advisable at all. We can able to utilize the register in between to make this thing perfect. But now we don't have to utilize the resistor because we have to reduce some of the voltage without fluctuation, right, to a limited voltage. So what I will do, we do have the regulator and in, out, and ground. So I will connect one of the wire, like I will take the black one and connect the wire in here to the ground pin. So I'm just connecting it to the ground pin of 7805 regulator, or I can rotate this thing up for better visibility. So I'm just connecting this thing in here. So now, okay. Otherwise, it will be great to connect the wires in here so that it will be good in all of the senses. So try to make your circuitry neat and clean so that a student won't get confused. So we connected the negative of the battery to the negative of the ground pin, and what we do have the in and out. So we'll take another wire, the red one especially, we will connect the positive wire to in of the transistor. So now we are supplying 9 volt directly to the transistor, this 7805 regulator, and we will replace this one. I will take the positive wire and connect it to the out of transistor, out pin of the transistor, and negative will remain constant all the time. Remember, all the things in our home, like the appliances itself, whenever we connect two or more appliances in our house, then what we will do, we keep the earthen position, earthen wire constant for each and every appliance, and we only tweak with the live wire. Means if we have to place the switch, we use the switch in between the live wire, and we suppose we have to go for the other things like the appliance which does have three wires, then yes, always tweak with the live wire, and we keep the earth and neutral wire constant all the time. So it will be connected directly to the power source. There won't be any issue on that. So now I just connected the wire directly to the negative terminal, and one of the wire is connected to out pin of 7805 regulator. Let's hit this start simulation button and see what happens. So again, the voltage is reduced, but the current flowing is not reduced because this LED is not ideal to being utilized with 5 volt as well. So if we bring our multimeter and let me check the voltage drop in between, then you will understand what I'm trying to do. So I'm taking the positive to the positive and changing the color black and connecting the negative to negative in here and hit this simulation, then you can see how much voltage is there. 8.27 volt is passing through the battery because the LED is withdrawing some of the voltage. The battery is rated to 9 volt, but LED is withdrawing some of the voltage for its utilization. So now what I will do, I will connect this positive wire to the output of regulator 7805 regulator and hit, if I hit this simulation, then you will see drastical change in the potential itself. So after conversion, what the regulator is doing in here, it is like reducing the voltage from 9 volt to approximately 5 volt. The voltmeter is showing 4.99 because the LED is withdrawing some of the potential. If we disconnect the LED, then it will give us the exact value of the regulation, like the 5 volt itself. So what we else need to do in here, we have to utilize one of the resistor. I'm bringing one of the resistor to connect it with the negative pin, and I'm changing the value of resistor to 100 ohm like I did in my last class. So I'm starting this simulation and you can see it is working perfectly, even though the resistor is not good for the LED now. So let me change the value again. Okay, let's make it 200 ohm. So what will happen? It will glow perfectly. It is glowing perfectly, right? So even though if you change the color, then it will look good. So now we balance the circuitry to like we are taking the 9 volt from the battery and further we are stepping down the voltage using regulator. We can able to achieve the same thing with the resistor as well, but resistor is not ideal because whenever we try to convert the higher voltage to a lower voltage using the resistor, then more friction produces inside the resistor, then the resistor will start emitting the heat. It will convert the electricity to heat energy and it will cause the losses of power in the electric circuit. So for ideal use, we should utilize some of the regulators in our electrical circuit or any of the project circuit to make it perfect in all of the senses. And you will get to know, you will understand each and everything while working with these projects, small project. Like through the experience, you will learn each and everything. So I hope each and everything is clear for now, and help me with your question, please. If you do have any other doubts as well, so let me resolve it by today. Then we'll
Yes,
proceed
I
further.
have a basic question out here. In this
Yes, ma'am.
example that you have showed here, you have connected the resistor after connecting the bulb to the positive side, and the resistor is shown to be connected to the ground at the later stage. So does
Yes.
this not mean that when the bulb is receiving the current, it is receiving it only as 5 volts, isn't it? Still it is receiving. So should the resistor not be connected before you send the power
Okay.
supply to the bulb?
Okay, you have to understand, ma'am, one thing in the electrical circuit. When we talk about some of the components, like if we look closely to the LED itself, then we can see there is two terminals, right? The bigger one, the bigger terminal is the positive side, and the smaller terminal is the negative side. And similarly, similar to this, and the name of this particular device is LED, and LED stands for light emitting diode, as I explained earlier as well. Light emitting diode. Remember this term, the diode term in this LED. So if we take the example of any of the diode, if you go through the Google search and just type the diode, then you can see one of the things in common. Like diode does have this particular thing. So let me paste this thing in here. So this one is the diode, and if you look closely to the diode, you will find there is anode and cathode. So remove the bijus. We are not promoting any of the any of the academy. So let it be. So now in diode as well, we do have is the anode and cathode. That means whenever this particular pin will be connected to positive and this particular pin will be connected to negative, then only this device will work. This is what we call the directional sense in electronic components, directional sense. So we have to maintain the polarities in some of the components, but not all of them. Register, on other hand, does not have any of the conditional or directional sense of connection. So
No,
we can.
My question was not that. I understood the polarity related to the LED. I
Yeah.
also understood the non-polarity of the resistor, which is
Yeah.
fine. But can you go back to the design? Yes. So if you look into this design, you can see that the anode, the resistor is connected after the bulb.
Yeah.
Right. So is it, my question was that when the bulb receives the current, it is actually receiving it as 5 volts, which is more for it, isn't it?
Yeah.
So should the resistor not be placed before the bulb?
Yes, ma'am. Yes. If you recall your concept in science, then we all why I connected this thing, the resistor in the negative terminal, because electricity is all about the flow of electrons. So current is not flowing through the positive side of the, but from the negative side. Not the positive side, but from the negative side. Even though if I replace this resistor from in here, like let me bring this resistor in here and just rotate it a little bit. And if I try to place the resistor and connect the wires like this, then what will happen? See, there will be no change on that. So let me connect this negative pin directly to the negative. So now it is connected properly. Even though it will work perfectly, there is no issue on that. If even though we will connect it to the positive source or the negative source. The reason why I connected it to the negative source, because the flow of electron, I'm keeping that in my mind, that electron is flowing from the negative side to the positive side. So that is why I connected this resistor to the negative side of this.
I understood it now. Yeah.
Connection. So it will not impact anything in between, ma'am. It will not impact anything. But for the directional, the reason why I was explaining this, the directional sense, it is applicable for some of the components, not all of them. So you have to take care of these things while going for the circuitry stuff in Tinker CAD, as well as in practical explanation. So apart from this 5-volt regulator, we do have many more regulators to like give us the different voltage output. So suppose if I bring 3.3 voltage regulator, and the same thing happens in this one, you will have the ground pin, out pin, and in pin. So let me rotate this for you. And now what we do have ground. So I'm just connecting the ground wire directly to the ground of battery. And further, what we do have in and out, right? So I'm connecting one of the wire to in, and change. Let me change the color. So I'm connecting the in to the positive of battery and taking the same wire to connect the out to in here. So I connected from behind. So if I take the LED now and place it in here, or else what I can do is to rotate the LED. So this one is cathode and this one is anode. So I'm placing the anode directly in here. So we need to connect the black wire to the cathode, or else I can able to connect it directly in here. So if I try to hit this simulation, so yes, now the LED is also glowing, but the current withdraw is 205 milliampere. For in this case, let me remove the wire and bring one of the resistor in here, and let me change the value to 100 ohm, and let me connect back this resistor pin to the negative of this circuitry. So if I hit the simulation now, so it will glow perfectly. There will be no issue on that. So we utilize the same amount of everything, but here we are receiving 3.3 volt. So that is why we are changing the value of resistance. Like in here we utilize the 200 ohm, and here we are utilizing 100 ohm. So even though 100 ohm is higher, so let's make it 50 ohm and hit the simulation. So 50 ohm is higher. You can able to calculate this capacity using the Ohm's law. You should go and you should follow the procedure of Ohm's law. Then it will give you the exact value it is required to run the LED. So now 80 ohm is working perfectly without any problem in the LED itself. So we converted 9 volt to 3.3 volt and 9 volt to 5 volt and two different circuitry and two different regulators actually powering up the circuitry. So whenever you will use microcontrollers or the microcontrollers directly without the programming board, which I'm going to mention in my future classes, first of all we will utilize the Arduino programming, but you should not limit yourself to the Arduino programming, but because that is manufactured by the company itself. If you learn how to like program the chipset, the EEPROMs, the electronically erasable programmable memories, then you can able to make your project too smaller in size. You just have to utilize the IC in between. Then only it will be effective for any of the project development. Otherwise, each and every person can able to see you utilize the Arduino. And right now in this world, everyone do have idea about the Arduino and the programming stuff, right? So make sure you are learning. If you are learning something, learn it from the core. So in here, any doubts? Anyone do have any doubts in between? Any more doubts? Is it compulsory to use resistor to convert 9 volt to 3 volt and 5 volt? No, we are not using resistor to convert 9 volt to 3.3 volt and 5 volt. Because my LED, the thing I'm utilizing, the component, the LED itself I'm utilizing to show you the conversion process does not work on 3 volt or 5 volt. We must reduce the voltage to 1.5 or 2 volts, approximately 2 volts at some amperage. So that is why I utilize the resistor in between to reduce the voltage further after receiving 5 volt or 3.3. Even though 3.3 volt is not good for the LED itself. So you must take care of those things while building any circuitry. So anyone else do have any doubt?
So
So
I
let me,
have a doubt.
yes, ma'am, please.
So if you can open my assignment potentiometer LED, I just have
Yeah,
a doubt
sure.
in it, please.
Okay, where it is, help me a little, ma'am.
It is potentiometer LED Jaya. Yes, sir. It's
This one?
yes, sir. Potentiometer. No,
This,
sir. Not this one.
okay.
Yeah.
Okay, this one, the
Please second.
potentiometer. Yes, yes, yes. This one.
Yes, sir.
Okay.
It seems to be some connection.
Not this one?
Yes, one.
Okay, let
Yes,
me
yes,
go
yes,
back.
Just wait. Just wait. No, sir, just open it. I just want a little. Open this, please. I have just
Okay.
a problem. So if you connect the power, means the positive power to the terminal 1. If you
Yeah,
connect it, please, if you can just edit it, right?
yeah. It is connected. It is connected from the behind itself.
Then in this case, if you start simulation, you will see that the LED is growing very light. If you just see, it's very light. Okay,
Yeah.
it's okay. Okay.
So you have to rotate this thing. You have to rotate this thing.
Okay.
One more thing I would like to add. Whenever you try to add
Sir,
some
it
of
is
the
connected. Sir, it is connected to the middle one, to the wiper, not to
yeah.
the. So please, if you just connect it to the terminal 1, it will show a change that the LED will grow a very little with very little intensity.
No, I don't think it will.
Yeah,
Means which
sir,
wire
it was
you're
showing.
saying, ma'am? Which wire?
So the positive terminal you don't connect it to the center one. You connect it
Okay.
to the terminal 1.
Okay, this one. Terminal
Yes,
2 or
terminal 2.
terminal?
Sorry. Terminal 2. I'm so sorry. Terminal
Okay.
2.
Okay, I'm deleting one of the wire. I'm taking another wire. I'm just connecting terminal 2 in here. So please, ma'am, if whenever you do the designing now, try to arrange the component perfectly. Otherwise, it will create a problem in there. So let me again rotate it a little. So now it is connected. So let me reconnect it. So I'm taking one of the wire. I'm connecting this wire to the negative one, right? Done. this simple, neat and clean circuitry. Take the positive one, I'm connecting the center to the positive, right? And again, I'm taking the red wire and connecting this particular pin to this particular pin. So now the circuitry is perfect in all of the sense. If I hit the simulation, then yes, it will increase its intensity as it will go further. Okay, let me tell you one
So
practical.
but this term, this wire, this connection to the potentiometer, this positive terminal. So please do connect it to the terminal 2. Just once
Okay,
try. It was blinking. It was glowing.
okay, let me connect this one to the terminal 2, right?
No, sir, not this one, sir. This was all
Okay,
perfect.
okay, okay, fine. The
This
middle one,
one, that
the
red
middle
one.
one,
Ah,
right?
ah,
This one to the terminal 2.
ah.
Okay, let
Yes,
me
sir.
hit the simulation. No, the intensity is very low.
Yes, why it is? But why it is glowing?
Why it is glowing? Because this potentiometer, okay, let me explain you something. Whenever you go for the potentiometer stuff now, there is one thing to remember. If you recall the thing, like what are the component it is made up of. So it does have three of the terminals: terminal 1 common and terminal 2, right? So inside of these thing there is some similar. I broke the potentiometer. A lot of potentiometer I broke. So I do know exactly what is happening inside. So it is like this. So in here we do have middle point and one pointer is connected in this one node. This one is node. So it does have this complete thing. Okay, let me change the color. This complete thing, this complete thing is a resistor. Is a resistor. So suppose if you are utilizing 10 kilo ohm pot or the potentiometer, the short form of potentiometer is pot. Suppose you are utilizing 10 kilo ohm of pot, then it means it does have A point and B point, and the resistance between A to B is 10 kilo ohm. So this is the meaning of potentiometer. Why? So whenever we apply some of the voltage in this section and try to connect the LED in this one, then what is happening? We are just reducing the resistance in between by turning the knob. If we go anti-clockwise, then we are supplying exact voltage to the LED pin, that is A. And if we move far away from the point by rotating it in clockwise direction, then what will happen? It will it will always increase the resistance in between and the light will go dimmer and dimmer. Okay, let me show you back again what is happening. If I connect this wire, you can see it practically as well. If I connected the middle wire, so the knob is connected to the middle terminal, that is the wiper. And first, the terminal 1 and terminal 2 does have the value of 250 kilo ohm in between. That is the resistance. Potentiometer is nothing but a variable resistance. You have to remember this point. So variable resistance means you just need to change the value in between. Or let me tell you one of the trick which I do use in my STEM classes, which will be great for you to start with. Suppose if we have to provide the positive to this particular wire, to the LED wire, then connect other pin. The terminal 1 is remaining, right? So connect the terminal 1 to the negative of battery. Then see what is happening in here. What changes in here. So you can control exact amount of voltage. And if you're running in here, it will go completely blind. So whether it is not working properly with the 9 volt, but yes, if I increase the potentiometer value, then what will happen? Let's see. Okay, let's say 10. So if I start the simulation, then you can see the LED intensity of glow is increasing drastically, right? So if I reduce further, if I reduce the value of resistance in between, then what will happen? So let's say 100 ohm, 100 ohm or 200 ohm. So now if I change the value, so you can see the changes. You can see the changes
Yeah,
now.
suddenly there is an I symbol, information symbol that is coming near the
Yeah.
bulb. What is it for?
Actually,
Warning.
the LED is not ideal to run with 9 volt, right? That is why it is showing us the exclaim mark, and through the exclaim mark, you can see the current through the LED is 45.9 milliampere. So we have to reduce the amount of flow by adding one of the resistor in between. Then only this circuitry will work perfectly in all of the sense. So I'm just dragging and dropping one of the resistor. So I'm adding the register in here and changing the wire from in here to in here. And I'm changing the value of resistance. Okay, let it 1 kilo. So now if you look closely, you won't get any of the exclaim mark or the error. Now it is solved. Now the problem is solved. So further, if I reduce the 1 kilo ohm to let's say 500 ohm, okay, and if I hit this simulation, then also it won't show me any of the exclaim mark. The time when it does the lower end, the intensity will completely black out, and further if we increase, it will increase the value of the glow, of the light intensity. So you can able to tweak it, tweak with a different stuff present in there, then only your circuitry will be perfect in all. So through this, what I'm trying to do, I'm trying to create a potential difference in between the pot, in between the potentiometer. Then only we can able to supply exact amount of potential difference to the component required. And the reason why we do use potentiometer in an electric circuit, because we have to generate some of the analog values, which I mentioned earlier as well. We will deal with the two of the system, that is the digital system and the analog system. Through digital system, we only work with 0 and 1s, means either the thing will be off, the component will be in off condition or in on condition. Otherwise, the analog system gives the flexibility to utilize in between voltage difference or in between current difference. So it will the analog system is the range itself, right? So we can able to create zero between range between 0 to 1 in analog system, and that is why the potentiometer in here to create the analog input to the Arduino or any of the devices we do use in our daily lives. So the volume thing in our mobile phone, and earlier we did have the televisions, right? That similar, the television also do have the same thing, like the knob is stuff to adjust the volume in between. So this is how we can able to proceed further with the analog circuitry. So anyone else do have any doubt in Tinkercad circuitry? So I thought to explain the rapid prototyping in details today, but unfortunately, or say fortunately, because each and everyone cleared their doubt in between, that is very important for you to have in this learning process. So apart from these, if anyone do have any doubts, then please help me with your questions so that I can resolve it by today. And from next class onward, we will focus only on the programming side, and we will start the journey of our programming. First, we will explore some of the scratch mean of programming. Then further, I will let you have the complete understanding of embedded C++ programming from basic to advanced. Basic means we will start with simple LED glowing. We will work with the digital and analog system. Then further, we will have app development session in which we will control the Arduino using the Bluetooth module or using the internet connectivity. And then I will introduce the Node MCU and ESP modules to let you have the complete understanding of IoT device in these classes, so that I will deliver my knowledge on that. If by any chance, if you still find this class interesting in future, then yes, we can able to go for the rapid prototyping complete classes, and you will learn a lot through that, because in these domains I'm good in. So maybe I found difficulties to explain certain things using my words, but yes, I'm trying my best to help you out resolve the doubts and queries. So anyone, teacher from the teacher side, ma'am and sir, anyone do have any doubts or anything with their project and the design itself? This design I like the most, the rocketry system. I will surely print this out in my 3D printer and will share that video with you how I like completed the printing process from the design itself. I will record each and everything in between and help you guys understand the concept of rapid prototyping using this model. Yeah, thank you, ma'am. Thank you, Nirmala, ma'am. Thank you so much. So I hope each and everyone's doubt is clear for today, and we do not have any further questions, right? So I will
Thank
call
you, sir.
this meeting. Okay, ma'am. Yes.
Thank you for your doubt clearance.
Yes, ma'am. Anything that comes, because the thing is, whenever we try to teach something to someone, it is not about what I am delivering. It is more about what you are getting from my side. Means you are understanding it properly, means it is perfectly fine. If you're having any doubts in between, then yes, there is some problem and there is some scope of improvement as well. And this is how I can also further improve myself by sharing my knowledge with you all. And maybe who knows, some problems are never being resolved, like some of the problems can be doubtful in terms of my knowledge as well. So I will try my best to cope up with the same and share my insight on the project itself. So I'm excited to go for the project development session so fast, because these basic things you can able to cover up through the PDF which I shared, the design stuff and the circuitry stuff. Each and everything in details is mentioned on the PDF itself. If you focus for 4 to 5 days, a week itself, then you will become the master of this simulation and you will learn each and everything, how to utilize each and every component. And then further, the time when I will start the programming lessons, that is crucial for you to have the programming lessons, because it will be only being used in your classroom program for senior classes, like for class 9 and 10. Because junior,
Sourbh, sorry to disturb,
yes.
interrupt you. Is it possible for you to quickly explain what is, I found a component called as RGB bulb. What is that?
Okay, RGB bulb is red, green, and blue bulb. So it will have 4 of the pins like this one, 4 of the pins. One will be the common point to all of the colors, like cathode, blue, green, and red. So suppose we do have the cathode. Let me rotate this real quick for the demonstration itself. So I rotated it. And now the cathode is in here. So I'm taking one of the wire and connecting the cathode to which one? Negative or the positive?
Cathode will go into the
It's
negative.
the negative.
Negative. So I connected it to the negative. Now we do have 3 of the pins. To make it impactful or like beautiful project, I do have one of the idea. Okay, let me bring one of the component, that is the DIP switch. So I am dragging 4 of the 4-pin DIP switch. Okay. Okay, let me delete the other components, otherwise it will create a mesh in here. So let the
I request that you create a new project and then do it, so that if I want to refer back to the ones, I may want to go back to the
sure,
classes.
ma'am.
Yeah.
Sure, ma'am. I'm doing that on. I'm reversing everything. Control Z. So now I'm deleting this one and changing this name. Regulator. So now I'm taking the another project. So this one is someone else's design, right? So that is why it is not showing to me to create a new design in there. So I'm going for the classes, STEM and robotics and activities, and adding new activities and RGB. So I'm creating this, sorry, I'm creating this activity, and under RGB segment, I'm creating this circuit. So now I do have blank canvas. So I'm just dragging and dropping the breadboard in here. So now the breadboard is in place. I'm bringing the RGB LED in here and rotating the RGB LED for proper connection. So I'm placing it on the downside, and then I will take one of the batteries or two of the batteries. The 3 volt battery will be enough. So I'm utilizing 3 volt battery in here for the application and taking this switch. You already seen how to utilize the switches, right? I already explained that. So we do have another kind of switch, that is the DIP. So DIP means it does have more than one phase, means we can able to control several electronic devices or electronic components using this switch. We do have 6 of combination, we do have single DIP, we do have 4 of the DIP. So through the combination, you can utilize these switches to help yourself connect many devices possible in the electronic circuitry. So right now I'm utilizing the 4 because I need only 3 of the connections. Otherwise, I can also utilize single DIP, 3 DIP switch in this application, 3 of them, but 4 will be enough for your understanding. So what I'm trying to do, I'm going to take one of the wire, normal wire, and connecting the first pin to second one, and then the second pin to the third one, and then third pin to the positive in here. Okay, so I hope you are understanding what I'm doing in here. So now we do have the cathode. So I'm connecting the cathode. Sorry, I'm connecting the cathode from in here to the. Okay, do not do this. Okay, leave this wire to the negative in here. So always try to connect the power into the power section only in the breadboard. Do not try to cross those things in the circuitry. So it will be neat and clean all of the times. So now I connected this wire. So now I'm taking one of the wire from the LED itself, or should I place this in here? Then it will be good. So let me recalculate or reuse the wire. Okay, fine. So now the cathode is connected properly. We do have one pin that is red, another one is blue, and the last one is green. So I am taking red to red wire and connecting it to, or else I can take red wire connecting into the first pin of DIP. Then I'm going to take the blue wire. I'm going to take the blue wire and connecting the blue wire to second pin of DIP, and third one is the green. So I'm taking the green wire and connecting the third pin to the third pin. So now I believe the connection is clear to all of you, right? So connection is clear. Let's add one of the basic thing, that is the resistor. Otherwise, what will happen? We will burn our circuitry on that. So I'm just removing this particular green wire, or just let it be. I'm just adding the resistor in between in here so that it will supply the exact amount of potential we need to run the LED. So I'm changing the value to 100 ohms for now and hitting the start simulation. So whenever we turn on the first switch, the red bulb will glow. Whenever we turn on the second switch, the blue bulb will glow. And when we turn on the third switch, the green will glow. If we combine two of the colors, then we can able to form any colors. See? So the green and blue combined forms the cyan, right? And green and red combined forms the yellow. And green and blue and red combinedly can able to make violet or purple. Maybe boys do have a problem with the color things. So purple. So blue and red will form the purple, and further blue and green will form the cyan. So you can able to combine three of the colors to form any color of your choice. So if we mix, if you do recall your concept in RGB color or CMYK color, the first composite color or secondary color, remember that term, the composite and secondary color, the primary color and the composite colors, like the secondary colors. So if we combine all of the three, then we can able to form the white color using the RGB. And same concept is being utilized in the printers. All of the printer does have a combination of 4 colors, that is cyan, magenta, yellow, and black. So using that 4 combination, it can able to form any color out of the rainbow or these color spectrum. So using the RGB, we can able to form the primary colors, that is cyan, magenta, and yellow. That is magenta.
What is the purpose of the fourth switch?
The fourth switch. This one, the DIP switch, ma'am?
Yeah, in the DIP, you have not connected the fourth leg, fourth switch
because
to anything, right?
there is no requirement of fourth one, because only we have to connect the 3 leg of this one, right? Because cathode is already connected to the power source, and we left with 3 of the options to connect. In RGB, there is 3 colors, mean 3 pins need to be connected with the switch itself. So that is why I connected it to 1, 2, 3 and left the 4 alone in there. There is no issue on that. That is why I shared. You can also utilize the single DIP. Let me remove this DIP from in here and connect the DIP like this. So DIP 1 goes like this, DIP 2 will go like this. So we can able to connect the DIP like this in single phase. Otherwise, it won't fit perfectly in the segment. That is why I utilize the 4 channel DIP switch in here. So we should not use the 1 for the RGB, but 3 of them we can utilize on continuous mode. I hope the concept of RGB is clear for each and everyone.
Yeah, it's clear. Thank you.
Any more doubts in this segment? Anything else, ma'am and sir? In case if you do have any doubt, then please help me with your question. Otherwise, I will conclude this session for today, and we will join back again in next week to summarize the other programming stuff. So no doubt so far. Thank you so much, dear ma'am and sirs, for joining this session, and have a good day. We'll meet again on next week, followed by the same. And in the meantime, I will try my best to provide the LMS access. I believe from the batch 2, some of you already got the LMS access, right? So the remaining LMS access will be provided to you by today, I believe. And also the assignment will be delivered by me only through the group itself. So just have some patience on that. I will help you out on that.
So I don't know about my batch actually.
Okay. So you started from the day 1 in this class?
Yes, sir.
Okay. Then you are from the batch 1. You don't have to worry about anything, because I will focus more on this batch to help you out.
Then it's okay. Then
Okay?
it's okay. It's okay.
So what's the difference between batch 1 and batch 2?
Okay. Let me help you with the doubts you do have with the batch 1 and batch 2. So earlier when I started these classes, okay, just allow me a second, please.